All right, so up right now is the work on 1.4 arithmetic sequences, however you wish to say it. And I think the first one I'm going to do is probably 4. No, not 4. The one after that one. 5. One about Felisa. I think that's how you pronounce her name. I don't know, I didn't write it. So with our half marathon quickly approaching, I know we got some kids in cross country. Maybe this will have some meaning to you. Talisa decides to train every day up to the day of the race. She plans to run 2 miles the first day and 3.2 miles the fifth day. Write the explicit form of her sequence. So the explicit form is ace of n is ace of 1 plus n minus 1 times the common difference d. That's the form I'm using. And I know she's running 2 miles the first day. I don't know the second day. I don't know the third day. I don't know the fourth day. And it's 3.2 miles the fifth day. I need to figure out what's happening here. I believe, doing the math in my head, she's going up 2.4, 2.8. Oh, no, we're missing some stuff. What's going on in here? Right? That's the difference. What's going on in here? 2.3, 2.6, 2.9. I had to figure out what the difference was. I just did that visually. I don't know that everybody can do that. Heck, even the math behind that would be a little bit harder. So if you can't do this, if you can't look at the sequence and figure it out, you have to use this formula. So if you can't write it out and figure out what the difference is, here's how you find it. You plug stuff in. You happen to have ace of 1 and you happen to have the last term. The last term was 3.2. It must equal the first term of 2 plus n minus, I'm sorry, this is the fifth guy, right? Plus 5 minus 1 times the difference. You can just do algebra. The truth is, that's what we made algebra for. We made algebra for when we just have a brain fart or something just gets too complex to look at the numbers. If we're not very good with patterns. We take away 2 and we get 1.2 and it must equal 4 differences. And then we divide by 4. Take 1.2, we divide it by 4, and we get 3/10. But that was the piece I needed. I needed that difference to write the explicit form. Because the true explicit form is that I take the nth term, whatever term I want, it's the first term of 2 plus n minus 1 times, and I'm going to write 3/10, just because I like fractions. And your book seems to think this is okay. So that's where we'll stop. All right. B, which day of training will she run the distance of a half marathon? 13.1 miles. So that's just as simple as putting that right there. So 13.1 equals 2 plus n minus 1 times 3/10. I kind of wonder if I shouldn't go back to decimals for the point of this problem. I think I will. You can take away 2, 11.1. You can distribute 0.3n minus 0.3. You can move that on over and change it to addition. 11.4 equals 0.3n. And then you can divide out the 0.3. 38. Looks like 38 to me. I feel pretty confident in that, but you know, if you're not sure, you just do the old school. How many times does, of course, it's kind of funny we have the decimal here, but 3 enters 11, 3 times, 9, 2.4, 8, and it's actually a whole number. Anyways, 38 times. Because I haven't shifted, whatever. It's 38 times. I haven't done long division with decimals in so long. I didn't do it when I was a kid either to some degree because it was just easier to do it in my head, doing the algorithm, shifting the decimals. I'm not going to do number 6. Let's see, your task here is to translate in between the two things. Uh, my only one I want to do here is this one. I left a blank here on purpose because you can always add 0. You can always add 0. And then I'm just going to write down the recursive rule in front of it. That way I can pick out my pieces. And they have the difference here. You can kind of think of this as your difference. So with that in mind, I know that the first term is 0. I know that the difference is 1 and 8. So now I can actually write my piecewise recursive rule. This is still called a sub n. It's got 2 pieces. I am 0 if n is 1. That's the first piece. If n is bigger than 1, I am the previous term plus 1/8. So if n is greater than 1. There's the recursive rule. 11 I'm going to leave for y'all. Let's go over sigma notation. So 13 is up next. You are supposed to look at this and you are supposed to realize it is arithmetic. Because it looks like y equals mx plus b. All arithmetic sequences look like y equals mx plus b if you crank out the math. All right. Plus, that's all you're doing right now. But anyways, the sum of n things in an arithmetic sequence is n over 2 times a sub 1 plus a sub n. Well, this is first, and this is last. All right. How many things are there? Well, n is 11 minus 1 plus 1, which is 11. There's 11 things. All right. And I need the first term and the last term. So I've got to find them off to the side. The first term, a sub 1, happens when I plug in a 1. It's 3 plus 2 ones, which is 5. The last thing happens when I plug in an 11. It's 3 plus 2 11s, which is 25. Then I can just plug it in my little formula that was given to us by Gauss. The sum of 11 things is 11 over 2. First term was 11. Last term was 25. 11 and 25 makes 36, so the sum of 11 things is 11 over 2 times 36. Half of 36 is 18, so it must be 11 times 18. 11 times 18 should be 198. Try and do this without technology. You have a brain up there, and once your brain starts working with numbers, everything just starts making more sense. Let's see, I will do the race car driver for you to help you with 16 to some degree. Although 16 will probably be asked in class, so be it. Race car driver travels 34 feet the first second of a race. It says he travels 3.5 additional feet each subsequent second. Notice how that's written out, which means the next time it's 37.5. All right. After that, we had another 3.5. I think we're sitting at 41. ... Until we get to the 52nd second. So that's what I want to figure out. How many feet did the driver travel in 52 seconds? How many total feet? They don't want to know what the 52nd term is. They want to know how many total feet. Because he's moving fast. It seems like ridiculously crazy. Actually, the way this is worded, this is what they want. They want the 52nd term. Because otherwise, it's just going to be a gigantic number. I don't think it's about adding. travels 3.5 additional feet each subsequent second. Yeah. Anyways, we're supposed to figure out what the 50-second term is. Pause this. I got this from your book, but I do not like the way they worded this. I was doing some math, and the question is actually about summation. I was a little bit worried that it was going to be so fast, but even at 52 seconds, given this rate of acceleration, he's only moving about 145 miles per hour. So it is reasonable that they're asking for total distance and he's actually accelerating. It was just worded wrong. So let's figure this out. I'm going to write a rule for this one. You doing all right today?
Yes, how are you?
Oh, I'm good. No, you're fine. We're going to find the explicit rule of the sequence we see in front of us. A sub 1 plus n minus 1 times the difference. And the nth term is going to be the 34 feet plus n minus 1 times the difference of 3.5. Now, if I want to know how many feet he's traveling in the 52nd second, I'm going to do a sub 52. And I'm just going to crank it out. In his 52nd second, he's traveling 212 feet, 212 and a half feet per second, which is a lot. And that's why I was kind of curious what's going on here about the mileage. He's going 145 miles an hour. All right. Back here, he's about 22, 23 miles per hour. So he's accelerating. And we're talking about a race car driver. 200 miles an hour is not outside of realms here at all. So we want to know how many feet this guy has traveled total. Well, we're going to do a series. There's 52 seconds. We're finding the sum of 52 seconds of travel. It is n over 2, so 52 over 2 times the sum of the first term and the last term. And that's what we're going to figure out, okay? Now, the bell is rang. It's after hours. I'm going to cheat. Let's see, math, num, n over d, 52 over 2. Parentheses, because I'm tired, 34 plus 212.5. 6,409 foot. And you know, like, wow, that's a lot. Not really. It's not a lot. You divide that by 5,280 foot per mile. He only traveled roughly 1.2 miles. It wasn't a lot. I mean, I can do that in my truck. My truck probably won't hit 145 miles an hour, but the acceleration here was too slow. The acceleration was just so low, and they did that so the problem actually had some sense at the end. It's not much, you know, he was just running a little bit over on average, 60-something miles an hour. Anyways, that's all I'm going to do. Between that and the ACT, you got most of it. Not a whole lot you have to do on your own. Try and figure it out.